All right, guys. So today we're going to talk about conversions, going from one thing to another. And we're going to start with a type of conversion that's probably pretty familiar to you. It's going from miles per hour to kilometers per hour. So before we dive into this question, is there anyone out there who's been in a country where they don't use miles per hour, that they use kilometers per hour? If so, I want you to either put it in the comments or just unmute and tell me, where did you go that they were using kilometers per hour instead of miles per hour? Anybody?
Japan.
You have not been to Japan.
No, I'm just kidding.
I wish I could go to Japan. I did go to South Africa for a while, and they go in kilometers per hour.
You went to Africa?
Uh-huh.
When?
15 years ago.
Oh, wow.
Yeah, it was awesome. But they go, not only do they go kilometers per hour, but they also drive on the left side of the road. So it was kind of a weird transition, especially when I came back getting used to it, because then my brain had gotten used to it. Okay, so now when you're going in miles per hour and you switch to kilometers per hour, is that going to be faster or slower?
Isn't it the same, or I don't know?
Not quite the same. So 1 mile per hour is the same as 1.60934 kilometers per hour. So if we want to see what is 25 miles per hour in kilometers per hour, we're just going to times it by 1.60934, which this is a good chance for me to let you know that we will be using calculators today, especially if you have like the TI-84 or the TI-84 app. That would be really helpful. So what I want to do is I'm going to take 25 and times it by 1.60934. Here's my calculator. And I hope I can remember that 1.60934, I believe is what it was. When I multiply that, I get 40.2. What that means is 25 miles per hour is the same as 40.2 kilometers per hour. The only difference is how they're measuring the speed. One is measuring miles per hour, one is kilometers per hour. Well, let's do the same with 40 miles per hour. 25 is what you drive in your neighborhoods. So 25 miles per hour, if you were kilometers per hour, you'd want to be about 40 kilometers per hour. What if you were doing 40 miles per hour? That's like usually what you do on streets that are a little more busy, but not necessarily residential. So if I do 40 times 1.60934, I get that's about 64.4. And again, that's in kilometers per hour. Well, what about if you get on the freeway? 65 miles per hour is usually what we're used to doing on the freeway. What would that be in kilometers per hour? Let's just do 65 times 1.60934. Oh, I put that in wrong. I only put 6. Silly Solberg. Okay, and that gives me, did I put that in right? 1.60934 times 65. I get 104.6. Nice. And I remember that when I was in South Africa, I got on the freeway and it said the speed limit was 100. And I was like, sweet, 100. Because you think that means you're cruising. Yeah, you're only going like 65. It's just your freeway speeds. But it feels cool to be in the triple digits. All right, now, why are we talking about that? Well, this was just an example of speed and how you can measure it in different ways. What we're going to do today is we're going to talk about how you can measure angles in math in different ways as well. So let me jump over for our objectives today. We're going to be able to convert angles from degrees to radians and vice versa. What that means is that we are going to be just like how we times by something to get from miles per hour to kilometers per hour. We're going to have a formula like something that we times by to make it so it converts back and forth. We're also going to talk about arc length. Now, if you have questions on special right triangles, I need you to stick around after and you can ask. You can also email me. There's also videos on the practice. Really, you guys just need to actually get on there and try it. It's not too bad. Okay, so speed, we talked about different ways we could measure it. We're most accustomed with miles per hour, but in other countries, they do kilometers per hour. Does anyone know, is there another way we can measure speed besides miles per hour, kilometers per hour? Like, I'm sure if you get into space travel, we have other ways. Didn't know if anyone knew off the top of their heads. Well, what we're going to do now is switch it up and talk about angles. Ooh, someone's in the chat. Time and distance. Yeah, I'm sure there's like other measures of time and distance we could use to get different speeds. Let's talk about angles here. Okay, so an angle is created by two rays like this. We have what we call rays going from the same point, and it makes an angle. Now, we want to know how big that angle is. What is the way that we normally measure angles? Someone just shout it out or put it in the chat.
Degrees.
Thank you. So we're really good at measuring in degrees because that's just what we do. If you go snowboarding and someone does a full rotation, you call it a 360 because you just did one full rotation, which is 360 degrees. What we're going to talk about is a different way you can measure angles, which is in radians. And you may not have heard of that before. Is there anyone out there who has worked with radians before? If so, just shout out yes or put it in the chat. What I found in
What's
my
that?
lab. Who said yeah? Manda, you said you have?
No, I asked, what is that?
I'm about to show you. Avery thinks she might have. It's been a while, so we could do a review. That's great. So here's a question. What does the word radian remind you of? What does it sound like?
Radius? I don't know.
Yeah, radius. There you go. When we're talking about a circle, the radius is a line segment that goes from the center to the edge of the circle like that. So here is a radius. Now, if I'm going to draw two radii, which sounds weird, but like think about octopus. If you have more than one, we say octopi, right? So radius is going to be radii for more than one. Anyway, but if I draw two radiuses or radii, notice what I have created here is an angle. And with that angle, we have created an arc. So this angle right here, we call it a central angle because it's in the center of the circle, okay? But notice how these radii made an arc. And we can make that arc bigger or smaller depending on the angle between the radii, okay? Now, what we're going to talk about here. Wait, do you say you can't see?
I can see your screen.
Okay. I'm like, are you saying you can't see me or you can't see my screen? Because if you can't see me, you guys control your own view of the participants, but you need to be able to see the screen. So if you can't see the screen, let me know. Avery, can you see the screen? The text box of meeting. I'm going to get rid of that. I don't know if that's any better. But hopefully if something's in your way, you can move it. Because for me, I don't know. It looks clear to me. Let me just go to this next page. What we're going to do, though, is we're going to create a radian. And as you guys told me, a radian sounds a lot like radius. And that's because what we're going to do is we're going to take this radius measure here. And what I'm going to do is I'm going to copy it over so that the length of this arc is also a radius. So it's almost like what we're making here is a sector is a word. It's like almost like a triangle, except it's curved. But notice how all three of these distances here is r, it's your radius. If you create it a sector like that where all of the lengths are your radius, then you have made 1 radian. Now, I'm going to show you a visual of what this looks like because it's hard to visualize right here, but I found this great website. It's called mathisfun.com, which is true, right? You guys are probably like, fake news, Solberg, math is not fun. Well, it has a great visual here, okay, that I think will help you out. So here is my circle, and here's a radius. And if I make the arc length here, the piece of the circle also be the length of a radius, then I have made a radian. And it's about 57 degrees, 57.29. But the reason I wanted to show you this, watch this. This visual will help you see. And you see that? Pretty cool. That's how you create a radian. Again, let's watch that again. So we're going to take our radius, we're going to copy it onto the circle, and that angle right there is called a radian.
Wait,
Okay?
Solberg,
Yeah.
does it start as a radius?
Yeah, it starts as the radius, and then we're going to copy it onto the circle, and that angle to connect it back to the center, that central angle there is called a radian. Okay? Now, I think it would be awesome if you guys took Aladdin and remade the song Arabian Nights to be Irradian Nights and made it a math thing, right? I bet it would go viral. You should do it. Okay, now go back with me. If I look at my circle in our notes, how many radians do we fit in 1 rotation? We know in degrees, there's 360 degrees in 1 rotation, but how many radians can we fit? We've got 1 right here. And if I copy it over here, there's 2, 3, 4, 5, almost 6. Look, there's 6 and a little left over. So in radians, 1 rotation all the way around it's 6 and a little bit left over. Now that little bit left over is actually 0.28. And that might not mean much to you, but it might look more familiar if I look at what is half a rotation. Let's take 6.28 and let's cut it in half, and it becomes 3.14, which is what?
Isn't that pi?
That is pi. So what we're seeing here is that in a circle, if we're looking at those radians, pi radians, 3.14 radians gives us a half a rotation, or 2 pi radians gives us 1 full rotation. So 2 pi radians is 1 full rotation. Pi radians is half. Now, let me go back to the Math is Fun website so you can visualize this. Again, so here, it's going to take one of our radians and say how many are in a half rotation. There's 1, 2, 3 and a little. That little bit is 0.14159. Goes on forever because it's irrational, but that is pi. So pi radians gives us the same half rotation as 180 degrees. And that's going to be our commonality here. That's how we're going to link those together, is that pi radians is the same as 180 degrees because they're both a half rotation. Let's watch that one more time. There's 1, 2, 3, and a little bit. Okay, so going back to our notes now. What this means, let's fill this out with degrees, okay? So what I have right here, this is like when we're graphing, this is our X and Y axis, and we've drawn a circle on there. But what we're going to do is we are going to put in the angles that we know. Let's start in degrees. So I'm going to let degrees be in purple, okay? We are going to start right here. That's 0 degrees. Now, if I go all the way around, I do a full rotation, how many degrees is that? Shout it out, guys.
4, I don't know.
In the chat, we see 360. That's right. So one rotation is 360 degrees. All right, then shout out, what is half a rotation? What if I only go over to here? How much is that?
180.
All right, 180. Now, what if we go halfway between 0 and 180? What if we do a quarter rotation? What's half of 180? Not quite 40. Anyone know?
90.
90 is correct. I heard Brock and Isabel put it in the chat. Nice job. So, and that should make sense because look, it makes a right angle, 90 degrees. Well, what about halfway between 180 and 360? That is going to be 3/4 of a rotation. It's actually just going to be 180 plus 90 more, and that is 270. So if we break down these angles, these kind of rotational angles, hopefully that's familiar enough to you that you've seen degrees before. But what we're going to do is now convert that into radians, okay? Now radians, we said, let's just kind of go through that same process. 0 degrees is the same as 0 radians. It's still 0, okay? But if I go the full rotation, how many radians did we say we could fit in there? That was 6.28, which we said is what? That was 2 pi. So one full rotation in radians is 2 pi. Well, then what's half of that? What is half a rotation? That is just going to be pi. Well, then what's half of that? Well, don't think too hard. Half of a pi is pi halves. It's just pi divided by 2. Well, then what about this one right here, 270? Well, if I think of these as halves, here's 1 half, here's 2 halves, then here is 3 halves. This is 3 pi halves, radians. All right, so now we're measuring the same angles. It's just showing how the measurement in degrees looks different than the measurement in radians. Now, the main thing you need to know for this is how to convert something from degrees to radians and from radians to degrees. I did this as kind of a background to try to help you understand what a radian is, to make it so it's less abstract. In order to convert, we're going to take this relationship, that pi is 180 degrees. And we're going to multiply that or multiply its reciprocal in order to convert back and forth, okay? So let me show you some examples of how to do that. If I am going from degrees to radians, so this symbol right here means degrees. And if I want it in radians, I'm going to multiply by pi over 180. Now, sometimes you're going to do this in your head. Sometimes you'll need a calculator. But your answer, you'll always want a pi in your answer. Don't put pi in your calculator because that will ruin your calculator. It'll get all messy and gross. No pi's in your calculator. Let me show you what I mean. I'm going to change 60 degrees to radians. So I multiply it by pi over 180. Now, I'm going to go on my calculator and I'm going to put in 60 divided by 180 and simplify. Maybe you guys recognize that 60 goes into 180 3 times, but sometimes we'll get fractions we can't simplify. I got a weird decimal, but if you have a TI-84, you can go math, enter, enter, and it changes that into a fraction. It changes it into 1/3. Now, I didn't include the pi, but my answer needs the pi. So I'm just going to do 1/3 times pi, which is pi thirds. So 60 degrees is the same as pi thirds radians. That's how you convert from degrees to radians. Let's do another example, okay? Here I have 60 degrees and I want it in radians. So I'm going to times it by pi over 180. So I'm going to do 135 over 180. Oh, I was typing too fast for my calculator. And I recognize that as 3/4, but if you don't, you do math, enter, 3/4. So I'm going to go back here and I have to include the pi with it. So this will be 3 pi/4, and that will be in radians. So those are the same angle measure, just one's in degrees, one's in radians. Okay, now this is when someone speaks up and they say, what if I don't have a TI-84? Well, two things. Number one, then you have to just simplify or reduce the fractions using those skills. The other option is they have apps which are basically the same. For example, if you have an Android, I'm going to put this in the chat. If you have an Android, there is an app called Wabbit Emu. And that sounds weird, I know. But if you have an Android, you should download the app Wabbit Emu. And it gives you essentially a TI-84 calculator. Let me show you what it looks like. So if you can see my screen here, I'm going to go Wabbit Emu. It even has a little rabbit. And look, now it looks just like TI-84. And I believe for those of you who have iPhones, I believe it's called Grapher. Is it Grapher 84 or is it Graphing 84? Someone tell me. Does no one have it out there?
I don't have it.
Do you have an iPhone, Mena?
Yeah.
Go to your store and search for Grapher 84 and see if you see something that looks like that.
I get graphing calculator x84.
Okay, perfect. Thanks, Avery. Yeah, graphing calculator x84. That's the one that you want to get if you have an iPhone. And I believe it should have all the same functions, and then that way you can reduce that way. But good old-fashioned just reducing by hand or using your brain is probably the best. So let's do one more. We've got 330 degrees. We're going to change that into radians by timesing it by pi over 180. We're going to reduce 33 over 18, or sorry, 330 over 180. They both have a 0. So if I want to do this by hand, I can cross that out and say, hey, they both are divisible by 3. 3 goes into 33 11 times, and 3 goes into 18 6 times. So this should be 11 pi 6. Just to check my work, I'm going to go into my calculator now, and we're going to do 330 over 180. Math, enter, enter. And sure enough, we get 11 6. We'll just put a pi on that. There we go. So does that make sense how we would convert from degrees to radians? We times by 180 and simplify. Keep your answer, keep the pi there, or else it gets ugly. Now, what if we're trying to go the other way? What if we're trying to go from radians to degrees? Well, in that case, we're just going to flip it over. And instead of doing pi over 180, we're going to do 180 over pi. And let's do a couple examples here and see what that looks like. So pi 6 radians, I'm going to times that by 180 over pi. Notice we have a pi in the numerator and a pi in the denominator, so we can simplify that. That'll give us 180 over 6, which, just doing some mental math, that's 30 degrees. All right, let's try that again. I'm going to go 3 pi fifths. I'm going to times that by 180 over pi. The pi's are going to simplify. But now I need to reduce this. If I say how many times does pi go into 180, or does 5 go into 180? 30 times would give it 150, and we'd still have 30 left over. So I think that's 36. Then if I do 36 times 3, I believe that's 108. But I'm going to check myself there because sometimes my mental math isn't right. So 3/5 times 180. So 3 divided by 5. And then we're going to times that by 180. 108. Sweet. Okay, last one, 8 pi 11ths. I'm going to times that by 180 over pi. And pi's cancel. I don't think I'm going to do this one in my head. So 8 11ths times 180. That gives me 130.9. Yeah, see, I'm not doing that in my head. So that's 130.9, and that's in degrees. All right. Now, this is usually when someone asks, they're like, well, I don't remember which one to use. How do I know if it's 180 over pi or pi over 180? So let me show you a trick I use, but you can always just look at your notes too, right? So if it's in degrees, then you don't have a pi. Notice when it's in degrees, you rarely would have a pi. So you need to give it a pi, which is why the pi is in the top, because you're giving it a pi. So you do pi over 180. If you're in radians, then you should already have a pi, so you need to cancel out that pi, so the pi goes on the bottom. So that's how I remember. If you have your own way to remember, great, or you can look at your calculator. Before I do some more examples, do you have any questions? Okay, then what we're going to do is on the next 2 slides, we're going to see that there's 8 problems. I am going to do 2 of those on each page with you, and then you're going to try to do the other 2 on your own. Okay, and what my hope is that the ones you do on your own, you can just shout out the answers once you get it, and then we don't have to like work through them all. But let me go through this with you. So again, if I was doing number 1, 225 degrees, I want that into radians. So let's go back. Which one do we use if we're going from degrees to radians? It's going to be pi over 180. So I'm going to just times that by pi over 180. Now I need to reduce that 225 over 180. So let's go into my calculator. 225 divided by 180. And I get 1.25. I want that as a fraction, so I go math, enter, enter, and I get 5/4. So this is the same as 5 pi/4. Remember, you don't put the pi in the calculator, but you do need the pi in the answer. All right, now number 2 is a little bit different because it has a negative. We haven't seen negatives. Well, if it's -4 degrees, then it's also going to be -4 radians. So just don't worry too much about it. You're just going to include a negative with your answer. So I'm going to do pi over 180. And I can cross out a 0 here because they both have a 0. And I can reduce 2 over 18 to just be 1 over 9. So this is going to become -pi over 9. Now, if you're like, Solberg, that was too much mental math. Well, then just in your calculator, do 20 divided by 180, math, enter, enter, and you should get 1/9, which when we times it by pi becomes pi/9, but don't forget the negative, okay? And I'm going to remember that this is in radians. If you run out of room, just put rad. Pretty rad. Okay, I'm going to skip 3 and 4 and just go and do a couple other ones. Do you always cross out the number they have in common? Yeah, so we're always going to reduce. Sometimes there's tricks like if they both end in zeros, then you can just cross out the zeros. But we're definitely going to simplify as much as we can. Let me do a couple more and see if that, hopefully that answers your question, Lizzie. If not, let me know. When I'm doing number 5, I have 5 pi fourths. I'm going to times that by 180 over pi, because when we're going from radians to degrees, the pi goes in the bottom. That way it can cross out. I'm going to try to do this one in my head. I might regret that. But if I look, yeah, go ahead.
What is the difference from the one we just did to this one?
So notice these ones are already in radians.
Yeah.
So this is going from radians to degrees, whereas the last 4, they were in degrees and we got them into radians.
Oh, all right.
That's why with the first 4, we did pi over 180. But with these ones, we're going to do 180 over pi. So you have to switch it. All right, now 180 divided by 4 is actually going to be 45. And if I do 5 times 45, 90, 180, I believe that's 225 degrees. But again, if you're like, I don't like mental math, then let's go in here and just put in 5 fourths times 180. And we get 225. Sweet. One more. -2 pi thirds. We want that. So this is already in radians and we want it in degrees. So we're going to times it by pi over 180. Or sorry, I said that backwards. I was writing it correctly. 180 over pi. So the pi's can cancel out. 180 divided by 3 is just going to be 60. And 60 times -2 is -120. I'm going to check that though. And let's just do -2 thirds times. So -2 thirds times 180. -120. Nice. Okay, here's how this is going to work. I'm going to give you 2 minutes. I've done 1, 2, 4, 1, 2, 5, 6. You're going to do 3, 4, 7, 8. And then I'm just going to have you shout out what you got. And as long as we agree, then we're good. And then we'll move on to arc length, which won't be too long. Okay, I'm setting a timer on my phone. 2 minutes starts now. Go. All right. That was 2 minutes. Did you guys do it? Can anyone tell me what they got for 3 or 4? Don't be shy. Just unmute yourself and shout it out, or you could put it in the chat. Or if you want to do 7 and 8, we can do those first. Just tell me something, guys.
I can try on 7, but I don't know some of the parts for it.
Thank you, Lizzie. I appreciate it. So what'd you do on 7?
So I did times 180 over pi.
Okay.
And then I crossed out pi on 20 over pi and then pi. And then I thought you were supposed to do like 9 and then 180 and divide it like with each other. And then I got 20, right?
Yep.
And then from that point on, I had no idea what to do.
Well, the only thing left over here is 20 times 20,
Isn't it 400?
which is 400. Yep. Nice job, Lizzie.
So it doesn't have to equal 160, right?
What does it have to equal 160?
So I was just curious if it could go over 360.
Oh, 360. Yes, I get what you're saying. Yeah.
Sorry.
It can be more than one rotation. Yep. We're actually going to do more work with like more than one rotation another time. But for now, yep, it can be more or less or negative, whatever.
All right.
Awesome. Thank you. While we're at it, let's just do this other one too. So I'm going to times that by 180 over pi. We can do the same thing where we cross out the pi. In this case, 180 over 6, that's going to be 30. So I'm just going to be timesing negative 23 by 30, which is going to be 0.96, negative 690. Is that what anyone got?
Yeah, I got that.
Awesome. Okay, there you go. That was 7 and 8. So maybe those ones were a little easier than the other way. So let's try going back to these and fixing our work. So here, we are going to times it by pi over 180 because it doesn't have a pi, so we're giving it a pi. 315 over 180. If I go on my calculator, 315 over 180 is 1.75, which math enter is 7/4. So this is the same as 7 pi fourths radians. Okay, now negative 495, we're going to do the same thing. We're just going to, in our calculator, put in, if you want to put in the negative, you can. If you don't want to, you don't have to. Just remember to include it in the answer. But when I do negative 495 over 180, we get negative 2.75, which is 11 pi fourths. So this is going to be negative 11 pi fourths radians. Oh, I don't need to circle that. Okay. I want you to put in the chat how comfortable you feel converting from radians to degrees and degrees to radians, 1 through 5. 1 would be you have no idea. 5 would be you're an expert. 3 would be you kind of got it, but kind of don't. So I think there's like, how many of you guys are there? There's 9 of you. So I should get 9 comments here. Okay. All right. So it looks like we got a pretty good range in there. Here's what, so we're not done yet, but this is where, let me kind of show you something. If you were to come onto our homework for today, This is where doing the homework really helps you out, because if you do it and you're getting it right, then it reinforces it. But if you're doing it and you're getting it wrong, well, then there's also ways to correct that. A, you could just ask me for help. B, there's videos assigned with it that can help. So let's just do one of these together and then we'll go to the next part. So in your module 6, special right triangles was day 1. Today we're doing radian and arc length. So I'm going to go down here to radians. And this is what your assignment is going to look like, okay? Let's just do some of those together. Convert 1.6 inches in radian, or 1.6 in radians, I thought that was inches, in radians to degrees, okay? Now, some of these, they're going to want you to include pi, and some of them, they're not going to want you to include pi, or maybe you can do both. So what do we do if we're trying to go from radians to degrees? I'm going to kind of show you the work out here. So 1.6.
Don't they give you the degree and you have to do pi over 180?
Yeah, so it depends on if you have, it's in radians or degrees. Now, in this case, it didn't have a pi, but it was still in radians. So in that case, we're going to do 180 over pi. Because if we're going from radians to degrees, you do 180 over pi. So now I'm curious to see which answers it will accept. If I do 1.6 times 180, it gives me 288. Now, if I divide that by pi, it's going to get messy here. So pi on your calculator is above the caret symbol. You have to do second caret. And I get 91.67. Now, I don't know if it wants 288 over pi or that other answer. So let's try the 288 over pi first. 288 over pi. And I liked it. It also would have taken the 91.67. So either of those are good because that's what we got as well. So you could put it with pi or as a decimal, okay? Here's another one that's radians to degrees. We already did that. Let's try one that's degrees to radians. Okay, so 302 degrees. We would times that by 180 over, or pi over 180. So I'm going to take 302 and divide it by 180. I wonder if I even need to simplify on here. Let's try that. If I just do 302 pi and divide it by 180, it likes it. So I didn't even have to simplify for these ones. Now, if you weren't getting it right, then come down here and click on this. This one, I think it's a worksheet, but other ones, they have like videos that you can like worked example. Here's some more like solutions to help you out with it. Okay, this one has a video. Okay, let me stop this for a second. Do you guys want to take a 2-minute break? Or do you want to just finish? Well, we can get through arcs in about 5 or 10 minutes. Would you rather just get it done right now, or do you want to take a 2-minute break? Put in the comment. Either put break or put get her done. Right now we're at, the majority of you are saying get it done. Okay, cool. So we'll get it done. If you do need to take a break, then go, you can go. You don't need to ask me for a hall pass. I am recording it and I'll post the completed notes. You can do that later. Let's just hurry and move on from here, okay? I'm going to teach you about arc length, and it's actually a really easy formula, okay? So let's go back to our notes. And again, just participate with me quick to get this done. We're going to first talk about circumference. What is circumference, guys?
Isn't that like the area of the circle?
Not the area.
Or the, I forgot.
It definitely has to do with the circle, but not the area. It's actually going to be the outside. So I call it the perimeter of the circle. Usually we talk about perimeter when we're talking about things like rectangles. Oh, brother. but here I think it's still appropriate. Perimeter of the circle. In other words, it's the outside. Now, the formula that they give you for finding this is that circumference equals 2 pi times your radius. Now, I'm going to show you something here. So this is kind of help you see a pattern here, okay? Let's find the circumference of these circles. We're going to use 2 pi r to help us find the circumference. So what we need to know is, what is the radius? Well, in this case, the radius is just 1. So if I plug in 1, 2 pi times 1 is just 2 pi. So this circumference is 2 pi here. This is actually a unit circle, because if the radius is 1 unit, we call it the unit circle. We'll be seeing that a lot. Okay, let's go to this next one. Again, we've got our formula. Circumference is 2 pi times r. But what is the radius in this second example? It's 2. And if I plug in 2 times 2 is 4. So the circumference is 4 pi. Now, last but not least, let's go to this biggest circle here. Again, circumference is 2 pi times the radius, but now the radius is 1, 2, 3. So if I plug in that the radius is 3, I'm going to get that the circumference is 6 pi. Now, circumference is the entire way across the circle. But what if instead of doing all of the circle, what if we just do part of the circle? Let's go to this next one. And you can see on these that we're just doing part of the circle. We're just doing this part. Okay. So then how is that going to work? Well, how much of the circle are we using? Like, think fractions here. How much are we using?
25%.
Good, 25%. Or in other words, how would you write 25% as a fraction? That'd be a fourth, right? 25%, a quarter is 1/4. So let's take each of these circumferences that we found and let's divide them by 4, okay? So the circumference here was 2 pi on the last page, but if I divide that by 4, it just turns into pi halves. For this one, our circumference, the whole circumference was given by 4 pi. But again, we're just using a quarter of it, so we're dividing it by 4 to get pi. So how much of the circle here, we're just using pi. Okay, last one here. This is our biggest piece here. This circle had a total circumference of 6 pi. But if I divide that by 4, because we're only doing 25%, it's going to give me that how much of the circle we're using is 3 pi halves. Okay, now, what does that have to do with anything? I'm trying to help you to see something here. Notice that in all of these, we use this same angle. What is this angle right here, guys? Someone shout it out. How big is that angle? That is 90 degrees. Thank you. But let's change that. Instead of thinking it as degrees, what was 90 degrees in radians? Go back with me to that chart we filled out. 90 degrees is actually, where was that? Right here. 90 degrees is the same as pi halves. Do you see right here, they're the same? So let's think of that angle as pi halves. So all of these, the angle was pi halves. The only difference was our radius. Well, in the first example, our radius was 1. In our second example, the radius was 2. And in the third example, the radius was 3. And notice to get this length here, this, we call it arc length, that piece of the circle, all we did was we took our radius times our angle in radians. 1 times pi halves is pi halves. Radius 2 times your angle, 2 times pi halves is just the 2's cancel, pi. Here, 3 times pi halves is 3 pi halves. And so what we've discovered here, guys, is our formula for arc length. S equals r theta. Now, if you're like, what does that even mean? Let me go to your next page. This is your formula for arc length. So when we're talking about S is your arc length. Remember, that's just part of a circle. So we're going to kind of get this. So arc length, S, that's this part right here, of a circle is given by timesing the radius, R. So I take my radius, and I'm going to times it by theta. Now, you have to be in radians. So I'm going to do theta radians. Okay? So that's pretty easy if we're given a circle with the angle in radians. For example, I'm going to just draw one super fast here, okay? Here's my circle. And let's say there's my radius. Let's say the radius here is 3. And let's say theta is, I'm just trying to think of something real quick, 5 pi fourths, okay? Actually, that'd be more like 3 pi fourths. I'm just making this up, so I'm, okay, 3 pi fourths. If we wanted to know the arc length here, the blue part is the arc length, we call that S. All we would do is we would times our radius 3 by our angle, which is 3 pi fourths. And that would give us 9 pi fourths. Great. That's how you find arc length. However, if you notice with all 3 of these, they are not in radians, they're in degrees. So what we're going to do is we're going to change our formula a little bit, and we're going to convert them in our formula. So I'm going to say S is equal to r theta, but remember to convert from degrees to radians, you just times it by pi over 180. That way it will convert it into radians so we can use it in the formula. Let me show you how easy this is, okay? Here's your formula, or sorry, here's your circle. It has a radius of 6, or I'm sorry, I'm messing up here. Radius of 8, and theta is 165 degrees. So to find the arc length here, that's going to be how much of the circle we're using. We're going to do S is equal to R, which is 8, times theta, which is 165. But since it was in degrees, we're going to times it by pi over 180. Now, in this case, I'm going to want to know what that is, like to a decimal. I don't want to leave it in terms of pi. So I'm going to go on my calculator, and I'm going to put in 8 times 165, and then times that by pi over 180. Remember that pi is going to be, I have to push second caret here, and then do over 180. And then that's going to give me 23.04. I'll just say 23. We'll round to the nearest 10th. So if the radius is 8 inches and the angle is 165, then this whole thing right here is that arc is 23 inches. Okay? Let's hurry and do 2 more. So for this next one, our radius is 14. And our angle is 315. Degrees, and what we're going to try to find is this distance all the way around. So we're going to put in S equals r theta, So that'd be 14 times 315 degrees. Then we have to times it by pi over 180. Because it was in degrees, we need it in radians. So on my calculator, I'll do 14 times 315 times pi over 180. Here's pi over 180. And I get 76.96. That's going to round up to 77. So even though the radius was only 14, going all the way around, that gives us an arc length of 77 feet. That's how much of the circle we're using, okay? Let me check, I did that right? 77, good. Okay, last but not least, radius is 4. Theta is 270 degrees. So again, since it's in radians, or sorry, since it's in degrees, we need to convert it to radians. So we'll do 4 times 270 degrees, and then do pi over 180. And I get 18.8. Okay. On your homework, there's going to be a story problem like this. And you might think, oh, I didn't mean to do that. You might think story problems are hard. It's not too bad. Let me just show you a quick example. It'll be fast, I promise. A Ferris wheel has a diameter of 100 feet. How far will a person travel if they rotate 75 degrees? The best thing you can do here is draw a picture. So I'm going to hurry and draw a quick Ferris wheel. So here's the center of it. And I'm going to draw a quick circle. Okay, that's not what I wanted. What is going on here? All right, now where we have to be careful here is it was talking about the diameter. We don't use diameter in our formula, we use radius. So if the diameter, what is diameter measured? The diameter is all the way across as 100, then what does that mean the radius is? Someone just shouted out, it's super easy. Yeah, in the chat, 50, half of that, so it'd be 50, there we go. Now, the radius is 50, but they're going to rotate 75 degrees, so that's going to be about to here-ish, okay? So we want to know what is that arc length right there. So again, we're just going to use the S equals R theta, but since we're in degrees, since it was 75 degrees, we're going to have to also times that by pi over 180 to convert that into radians. So just plugging that all in, we'll have 50 times 75 times pi over 180. Uh, 65.5, we'll say. So they traveled 65.5 feet by rotating 75 degrees. And that is how you do arc length. So now you should be able to have this down. Sorry, I may have gone too fast. Let me just leave that there for a second. We have covered 3 things today. With radians, we learned how to go from degrees to radians. And then if our angle's in radians, and how to go from radians to degrees. And then lastly, how to find arc length. So just to wrap this up, degrees to radians. In degrees, we don't have a pi, so we give it a pi. Radians to degrees, it already has a pi, so we take away a pi. And then just remember that your formula for arc length is S equals R theta if you're in radians. But if it gives you theta in degrees, then you just times it by pi over 180. And then it will convert it and give you the arc length. So I'm going to see you again on Monday. What I need you to do is do the radian and arc length assignment. And if you didn't do the special right triangles, you also need to get that done so you don't fall behind. Okay. I'm going to pause here. Thank you guys for actually being here and participating. I hope you're learning. I think it'll be better next week when we're in person, but hopefully this way you're at least still learning something. Okay. So if you have questions, stick around. If not, have a good weekend. I will see you Monday. Please do your homework.
All right, peace out, Sorek.
Bye, Sama. Thanks.
I'm gonna go play.
Bye, Lizzie.